Good evening to one and all. Thank you so much for coming to NTU on a Friday evening. My name is Ken Lam. I'm from the local community engagement office. Now, before we start our lecture proper, just a couple of housekeeping matters. In case of emergency, there are exits behind you. And of course, we are side doors as well. And I also like to request that you switch your electronic gadgets to silent mode, if at all possible. Again, welcome to NTU. For those of you who are visiting NTU for the first time, I would also like to encourage you to take a look at NTU campus. We are one of the top 15 most beautiful campuses in the world. And NTU has been transformed into a mini city over the last few years. So do spend some time exploring NTU. Now, NTU has been doing very well in terms of education and research. And one of the things that we want to do is to leverage on our strengths in these two areas to benefit our community and, of course, Singapore. So the Did You Know Monthly Talk series is one of the many initiatives that we have rolled out. So we started the talk in July last year. And every month we invite one of the top professors in the university to share with you his or her research areas. And we hope that in so doing we are able to help Singaporeans appreciate research as well as its benefits. Now the program, the flow of this evening will be as follows. So I will give a brief intro about our speaker. Following that, there will be a panel discussion. We have invited two prominent panelists as well. And then, of course, that will follow by Q&A from all of you. So feel free to ask questions. The lecture will take about 45 minutes to an hour. And, of course, follow a panel discussion as well as Q&A. We try to finish by 9 o'clock. As I understand, some of you have to take the public buses. Okay. Now, without further ado, let me first of all introduce our speaker for tonight. We are very honored and privileged to have invited our Dean of College of Engineering at NTU, Professor Phee. Now, Professor Phee is going to talk about cutting-edge technologies geared for the fourth industrial revolution. Prof. Phee is the Dean, as I said, of our College of Engineering. Prior to his deanship, he has served as the chair of the School of Mechanical and Aerospace Engineering. He graduated from NTU Singapore with Bachelor of Engineering Honours and Master of Engineering degrees in 1996 and 1999 respectively. He obtained his PhD from Scuola Superiore St. Anna, Pisa, Italy in 2002. I hope I've pronounced the name correctly. On a European Union scholarship. So I'm sure he speaks very good Italian. He is currently, his research interests include medical robotics and mechatronics in medicine. He is currently a recipient of the prestigious National Research Foundation Investigator Award. Prof. Phee had previously served as the program manager of A-STAR's inaugural MedTech program. He was the founding CEO of Endomaster Private Limited, a company he co-founded to commercialize a surgical robotic system he developed. Professor Phee was awarded the Young Scientist Award in 2006, the Outstanding Young Person of Singapore Award in 2007, the Nanyang Outstanding Young Alumni Award in 2011, the President's Technology Award in 2012, the Nanyang Innovation and Entrepreneurship Award in 2013, and the Nanyang Alumni Achievement Award in 2017. Now, shall we put our hands together to welcome our speaker for tonight, Professor Phee, please.
Thank you, Ken Lam, for the introduction. Very warm welcome to everyone. We have people from the neighborhood, public. We have also students, fellow colleagues, fellow professors here. It's a Friday night, so let's let our hair down and let's have a more interactive session. Okay. So what I'm going to do in the next 1 hour or so, I'm going to go through what is stated here. Talk about technologies geared for the fourth industrial revolution. I'm going to share with you my work. Okay, as Ken Lam introduced, I work in the area of medical robotics. Okay, and then thereafter we'll talk about the other technologies that we are developing here in NTU. Okay, so everything that I will talk about today, it's done and it's developed in-house in NTU, right? So you've heard about the Industrial Revolution. The first one was in 1784, pretty long time ago. Okay, so at that time, what came into the picture? Mechanization, water power, steam power, right? So those were the days with Mark Twain, where you see boats driven by steam rolling on the river. And at that time, the main industry was the textile industry, all right, in the West, in the US, in Europe, where you have cotton pickers. There was slavery then as well. Okay, so a lot of people were employed to pick cotton, okay, bring the cotton to the factories, and the cotton buds were processed very manually. Okay, so then came mechanization and water power, steam power, and some of these jobs were taken over by steam-powered machines. So what was the result? Well, you guessed it. Okay, whole loads of employees were laid off. Okay, because machines took over. Right, and then what's the next one? The next revolution came in 1870. What happened then? Electricity came into the picture, right? And then with electricity came motors, and with motors came a lot of factory automation. So a lot of mass production. This was when the steel industry came into the picture as well. Okay, so again, the machines were taking over production, mass production. A lot of products were produced by these means. And as you guessed it, a lot of people were laid off. Okay, and but then we survived, didn't we? Okay, so what I'm trying to say here is that in the first two industrial revolutions, although a lot of people were laid off, there were new jobs that came about. Okay. The third industrial revolution, 1969. That's where there was the advent of computers. Okay, automation, the digital world came into play, right? So data that used to be on drawing paper and charts, okay, everything could be put into a floppy disk. And of course, technology advanced further with more automation, and even though it was introduced in 1969, I would say that most of us didn't have computers then as well. Okay? Even right up to the early 1980s, many families still did not have a computer at home. So it took time for this third industrial revolution to come into full force. And as we go along up to today, you can see that digital power has improved exponentially, really. Okay? What used to store data in the old days, the same amount of data that took one whole basketball court of equipment, okay, now can be stored into something that fits into your pocket. Okay? So we have definitely improved tremendously. Fast forward to today. We are definitely in the advent of the fourth industrial revolution. So what's the difference now? Okay, the difference is that we are going to combine the physical systems, okay, or the robots, machines, and whatever, things that you can touch, the cyber systems, the digital world that has evolved since 1969, the third revolution. But what's new? The biological systems come into play now. Okay? And we're going to converge all these three systems together to make it very, very exciting. Okay? What do we mean by biological systems? We are talking about ourselves. Whatever we do, we human beings, biological systems, should be in the middle of all this progress. Okay, so with all the first three revolutions, as I said, jobs were lost, but new jobs came about. And you can see this happening even in Singapore today. Right? So jobs of the future. I would say that 70% of young people currently entering the workforce in jobs, they will face they'll be radically affected by some form of automation. Okay? And in the next few years, digital literacy will become even more important. Okay? In fact, more than half of the world's workforce in the next few years will need to be able to use, configure, or build certain form of digital systems. Okay? So that's what we are looking at. This was in the papers recently. Okay? Remember, just 5-6 years ago, you go to a bank, any branch, POSB, whatever, you see all the tellers lined up. Okay? In recent years, you notice that a lot of the branches in the banks, they have gone through renovation, and the number of teller counters have reduced, correct? Okay? And then they put in more ATMs and machines, and also people like this lady over here. Okay? So she was a teller, and now she has been converted to a digital ambassador. Okay? This is to help people get into the digital world, especially the older generation. They're not so used to internet banking. So these are the people. So you can see that as we lose jobs, brand new jobs come about. Okay? This was just in the papers a few days ago as well. Okay? So today we have jobs that never existed. We have drone pilots, okay, the top one over there. And then we have this gentleman over here. His job is really to develop maps for driverless cars that will inevitably run along our roads. Okay? And then most of us do online shopping. I do online shopping as well. Okay? I seldom go to NTUC FairPrice. Okay? I do everything online. And somebody got to pick up all those groceries that I ordered, right? So now we have these bee pickles. They'll go around picking the orders from what we order in the internet. So all these are new jobs that are being created. All right, so very, very interesting. So as we move along with each industrial revolution, there's no stopping it. Okay? We just have to go along with it and move along, like I say. So a little bit about myself. Of course, PM Lee says that engineering matters for Singapore's future. Okay, no doubt about it. A little bit about myself. Okay, my interest in medical robotics started with this clip that I saw as a young boy, Star Wars. Remember? Darth Vader cut off Luke Skywalker's hand. Okay, before that, he told him that you are my son. Right? And when I watched this as a 9-year-old boy, I remember, I thought, wow, that's great. Because it's okay if your hand gets cut off. The robot will just fix it back. Right? So I thought, wow, when I grow up, probably I would like to build such a robot. Okay? So that's how my career started as a roboticist, focusing on medical robotics. Okay, so I'm going to share with you very quickly some of my work. Okay? Colonoscopy is a big problem, even in Singapore. Right? One of the silent killers, we call it. Okay? The thing about colon cancer, the thing about colon cancer is that if you detect it early, you can be safe. In fact, the cure rate is pretty high. But now up to now, the gold standard is really to go for colonoscopy, where a tube is inserted into your anus and then it moves around right up into your large intestine to look at the cancers, right? So you can imagine the patient has to be awake. It's very uncomfortable to have this tube pushed into you, and it really depends on the skills of the patient. Skills of the doctor. Okay, and so I thought at that time, well, the best thing is really to automate this. Instead of depending on the skills of the doctor, why not build a robot that you can push into the anus and you'll crawl yourself up? Practically, I don't want to say that. And you will have a camera and it will inspect your large intestine for cancer. Okay? So at that time, I thought, okay, let's embark on this. And it was interesting. This was my PhD time, okay? And there were other universities, MIT, Harvard, and so on. They had this thing, okay, who can build the first robot that can travel into the large intestine, okay? And they were very good, okay? But I took a different approach, okay? I thought to myself, it's like building a Ferrari, okay? Before you even build a Ferrari, you have to understand the terrain. So I did a lot of basic experiments to understand the colon first, the large intestine, okay? Whereas the other universities straight away thought, okay, colon is like a tube. Let's build a robot that can run quickly in a tube, okay? So apparently it is not so. And I proved them wrong. So I also look at nature, and it seems that the inchworm is a good mechanism, okay? The way it moves from leaf to leaf, that is something that we can imitate. So more equations, in the end, built prototypes, and in the end I tested them. That's me over there, 18 years ago. Also 18 kilos ago. Right? And in the end, yes, we did build a robot, okay, like this. It's disposable, you have a camera, and all you need to do is to put it into the anus, and then you use a joystick like this, okay, to control forward, backwards, and it's good enough to look up for colon cancer. Okay, the best thing is it's cheap enough to be disposable, so you don't have to worry about cleanliness and things like that. Okay, so since then a company has been formed, okay, and it's selling in Europe and in Japan as well. It has not come into Singapore yet. Right? So this is one example. Next project that I'd like to share with you is in the area of urology. Okay, a bit of biological lessons. Okay, the prostate, that's the walnut-sized organ just behind the teeth, the testicle. And I always say that God is fair. You know, women, there's this problem with breast cancer. For men, it's prostate cancer. Okay, so how do we detect prostate cancer? You need to do a biopsy, and that is to push a needle. Yeah, I see all the men cringing. Ooh. Yeah, basically you have to push in a needle, okay, into the prostate to get a sample of the prostate. Okay, now, being a walnut, the size of a walnut, okay, the cancer, prostate cancer is, when you say you have prostate cancer, it's not the entire prostate that is cancerous, it's portions of it. Right? So if you're going to take a sample from a part that is not cancerous, then you're not going to be truthful to yourself, right? So it's very important to go to that area, okay? So I liken the prostate, if you slice it up like that, right? Can you see this outline over here? Can you see the outline? Right, that's the prostate from an ultrasound view taken transanally, okay? So if you sweep, you see this dark image, and that's the prostate. To me, it looks like Singapore, right? And from certain imaging modality, you can pretty accurately predict that your cancer is probably, let's say, is in Bedok. Okay? So your needle has to go to Bedok, which is somewhere here, right? You know, huh? Okay? If your needle doesn't go there, and it takes a biopsy sample from Toa Payoh, you know, then they will say, oh, you have no cancer, and then the poor patient dies 1 year later, correct? That's called false negative result. Okay? So with robotics, this is what you can do. First, you get information about the prostate, then you create a CAD drawing of the prostate where you can turn, you can enlarge, you know, things like that. And then the urology can pinpoint, okay, I'm going to have my needle go to Bedok, not only Bedok, okay, Bedok North Street 22. Very accurate, okay? And then the robot will calculate the trajectory, how the needle will go in. There's movements as you push in the needle. All this will be calculated. And finally, this is a real a real human trial. Okay, and in the end, we built a robot that can very accurately place a needle where it's supposed to go to the accuracy of 1 mm. Okay, which is good enough to ensure that you take the right biopsy. So again, it became a company, so it's selling. Yeah. So all these two examples, when it got pushed to commercialization, I was not involved. So I told myself, okay, the next thing that I did, I better get involved with the commercialization. Okay, so I came back to Singapore, and then I said, okay, let's do something interesting. So that's where I met my friend Lawrence, the doctor from NUH. He is probably one of the best gastroenterologists in Singapore. I asked him, look, let's work together. I'm the engineer, you're the doctor. Okay, how can I help you? And then he told me, well, being an endoscopist, you push these tubes from the mouth, you can look inside your stomach, you push it the other end downstairs, okay, you can look right into your large intestine, but there's nothing much you can do. The most you can do is a biopsy. You have a tool, grab some tissue and pull back and then see whether it's cancerous or not. But let's say it's not cancerous, it's benign, you want to take it out, you can't do anything. That's where he will call his surgeon friend, hey, can you help me take this tumor out? Right? So he's telling me if I have arms that come up from my endoscope, that would be great. Okay? That means I put in the tube into the stomach and then suddenly my arms come inside the stomach, from within the stomach, and then I can do some surgical operation. So that's what he was telling me. And then we were having chili crabs. Then he looked at the chili crab, I got very excited. He said, hey, Louis, this is exactly what you need to do for me. I don't need a very sophisticated thing like our arms. Just build this chili crab and then miniaturize it and put it in front of my endoscope, okay? And it just have the dexterity, enough dexterity and maneuverability to do what I need to do, which is lift tissue and cut things, right? The crab is good enough just to lift things, cut and put it in the mouth. That's all you need to do for surgery. Very, very basic. So I said, okay, come, let's start this crappy project. Okay, and then fast forward, okay, after a few years, a lot of trials and errors, we fail, some we succeed, okay, we tested on animals. In the end, we were brave enough to test on humans. Okay, we tested on 5 humans in the years 2011 and 2012. And we thought, wow, it was amazing because to get cancer out of your stomach or the colon, you need to cut open, right? You either make holes or you cut open. But in this case, no holes at all. It was using natural holes like your mouth and anus to access inside. And then we did 3 patients in India, 2 patients in Hong Kong. Out of these 5, 2 patients went home the same day for removal of gastric cancer. Again, wow, never happened before. So we got very, very excited. Okay, just to show you one of the trials. Okay, you had your dinner yet? Okay. Might spoil your dinner, I apologize. All right, so you see that this is the scope it goes in through. The patient is about 45-year-old lady in Hong Kong, and this is the surgeon. Okay, the surgeon is not near the patient, as you can see, he's controlling a very sophisticated joystick. So it's like a very expensive video game, but in this video game, you cannot lose. Okay, you must always succeed. So you can see that this is in the stomach, and this is the real cancer. And you have to slice this cancer. You can't slice through. If you slice through, you make a hole in the stomach, and then we are all in trouble, right now. Okay, so it's like slicing the skin of an apple without damaging the inside of an apple. Okay, you see this black hole over there? That's the duodenum. Okay, it opens and closes. You can see the patient is alive. Everything is dynamic. Though the duodenum is the entrance into the small intestine, so we are at the deepest part of the stomach already. Okay, so you can see the robot arms, okay, this cracked claw. The right arm, okay, is controlled by the surgeon here. The right arm is a pair of graspers, whereas the left arm is a cautery tool, high current electricity where you can start slicing things. Okay, and this is the device. So it's made such that you can feel, the surgeon can feel what's happening. So as he pulls on tissue, outside, okay, on this console, he can also, the machine actually pulls back, so he has the feel of actually pulling the tissue. All right, so just fast forward, okay, in the end, yeah, this is how we cut out the tissue, slowly but surely. Okay, and then we leave a crater over there. Yeah, great up. Okay, so this is when it came out, the victory wave. Okay, so fast forward, it is now, you know, we formed a company, as I said, I definitely wanted to be involved, okay, and it is now like that, okay. So we started off with, like, say, a 25-year-old Toyota that can break down anytime, but now it looks more like a Ferrari that just came out from the factory, all right. Okay, and yeah, just to give you a view, it's not the latest prototype, but it looks a lot professional now. So it goes in as a tube, and then all these instruments will suddenly come out and start to do your, you know, all your surgery. So that's me. Okay, I'm not having my hair perm. I'm doing the actual experiment on pigs, and after so many years, I can tell you that with regards to this particular surgery, I am the best surgeon in the world without a medical certificate. Oh, and last week, yeah, they gave us another prize. This is where you clap. So we should all be proud of this, because this invention was made in NTU. It's a made in Singapore product, okay, and nobody else in the world has it, okay, and the product will be in the market next year. So what is it next for medical robotics? Okay, so in the past 15, no, more than that, almost 20 years, I've been doing this medical robotics, building all these small little things, shrinking things, miniaturization, putting microprocessors into your body, you know, actuators, sensors, and things like that. What is it next for me? Okay? I can tell you it is very exciting. It's also very, very scary. Okay, you go to a surgeon now, okay, and normally if you have something very serious, the first question, who is the best surgeon I can find, right? Okay, and then obviously the famous surgeon will be, he'll demand more, right? Okay, why is this so? Why is he so-called better? No, the more experienced surgeon is better because he or she has seen more. Get it? For a particular procedure, you say, I'm one of the best surgeons in this area because I have done 1,000 patients, correct? And therefore I've seen more, so I know what to do. So when it comes to what to cut, when to cut, how big to cut, how small to cut, which angle to cut, and things like that, I will know better because I've seen more. Now, with the advent of artificial intelligence, data science, machine learning, and all these things that you hear, if let's say all these patients that are being done all over the world, all this data is congregated into one portal, okay? And the system is available to a system, okay? The system will then have the experience of 1 million patients. So you tell me, who will become the expert? The surgeon with 1,000 cases behind him, or the system, you know, the computer system that is hooked up into the internet with all this big data with 1 million patients of the same. Obviously, more data means more accuracy, higher accuracy. Okay, so the way I see it, okay, the device that for example, the crab robot that I show you, is still the surgeon that is doing it right now. And he can be in another room. Okay, now the technology allows that this surgeon can be in another country, and then the patient is in another country. It's fine. Okay, all these are just technology. But with all this new information technology, you can take away the surgeon. Okay, let the robot decide by itself based on the data. Okay, so it's no more a master and slave device. It's just the robot being totally autonomous. This is what's coming ahead, okay, which is scary, right now. But again, it's how we do it, and it takes time for acceptance. Robotic surgery, 20 years ago, if I'm going to tell a patient a robot is going to cut you, he's going to say, you're crazy. Today, patients are knocking on the door. No, I don't want you, surgeon, Mr. Surgeon, to do the operation for me. I want the robot to do it for me because it's more accurate. Okay? So in the future, now I'm telling you, it's going to be a totally automatic. It scares everybody. It scares me also. But in time to come, okay, with the technology proven, okay, let's say in 10 years, 15 years time, it could totally be autonomous. Okay? And that's where it fits the theme of the fourth industrial revolution. Okay? So far, what I've been doing involves the human and the hardware. Okay? But now you have the cyber space coming to play as well. Okay? So going forward, some of my colleagues work also circles around artificial intelligence for ourselves, for health. Okay? So countries like Singapore, we have an aging population. Okay? After yesterday's news, seems that it's getting worse. We are having fewer babies and there are more singles, right? That was reported yesterday. So we have to take care of ourselves. Okay? So the mission in some of our activities in NTU is really towards an ageless, aging society. Okay? We will get old, but we don't want to be cut off from the rest of the world. Okay? So as we grow old, we will face some of these real problems. Okay? Dementia, stroke, frailty, mobility, loneliness. That is an issue as well, right? Okay, so how can we use technology, especially artificial intelligence? Okay, there are projects that makes use of in-game behavioral markers. It's like playing a game or your interaction with some interactive system. And as you interact with this game or online system, they will pick up very intelligently traits about you, yourself, and they will map it to your medical history records. And from there, again, it's all about data. They can accurately predict when are you at risk for a second stroke. Okay? There are devices, very simple, mobile devices, games that help in rehabilitation. For example, in this one, okay, the game, requires this patient has some problem with the knee. So to rehabilitate the knee becomes the fishing rod. So you have to move your knee, which is the fishing rod, to catch the fish. All right. Very nice name, Funny. Okay, and then there's an idea of actually sensorizing the home of the aged person. Okay, putting sensors all over, okay, and collecting data. Again, very, very importantly, you can imagine, even if you are old, okay, you have mobility problems, but you still want to live your own life. You don't want to be watched by a video, a camera, right? Privacy is still very important. But if we can introduce very subtle sensors, like the system will know if you open the fridge, the system will know that you open the blinds, and there's movements in this room, that room, and when you turn on the TV, what channels did you engage in, what are you watching, what do you take up from the fridge, and the system can somehow pick up patterns, okay, without the intrusion into your privacy. And these patterns can again be connected, shown and analyzed and connected to your loved ones. Okay, so your loved ones might get a message like, oh, okay, your old granddad, somehow the pattern has shifted. He's supposed to wake up around 9, but today he slept until 11 o'clock. Maybe there's something that you want to look at. Okay, so all these are going to be put in place. Okay, we already have test house, mock-up houses with real people who are living it. Okay, the thing about technology is that sometimes you just can't throw in technology for the sake of throwing in technology. Ultimately, we are still humans. Okay, so there's a lot of testing to ensure that we can adapt to this new technology. Otherwise, better take it away. Right? This is another example. I'm also involved in this project. Very, very simple. It's just a joystick for upper limb stroke rehabilitation. That means that after a stroke, you can't use one of your arms. Okay? So the idea is to grab on this joystick. You can move the joystick. The joystick can also move your arms. Okay? So by using this joystick to play some games, like track a road or something like that, the system picks up which directions or which movements that you are not so good in. Okay? And from there, it can more or less know exactly which muscles are weak. And as you play the game gets configured to particularly train those muscles. Okay? So that you rehabilitate and you get better faster, rather than just to go for your physio and you're training muscles that are already healthy. So it's more targeted. Okay? So again, this system is in trials. So for such things, we are working with Alibaba. In fact, Alibaba just signed a large lab with us. Okay? We're very proud because this is the first time Alibaba worked with a university that's out of China, and it's NTU. Okay? So we're looking at home AI, health AI, artificial intelligence, crowd emerging AI, things like that. Mobility, that is something very interesting as well. Okay? And that is something that I think Singapore can be a leader in. All right? We're talking about mobility, self-driving cars, okay? Bicycles, buses. Okay? All this, it's a matter of time, I would say. It's just a matter of time where you see all this really on the roads. In the roads in NTU, these are already going around, okay? Driverless cars. Of course, this is still a test bed within the university, but soon we will go out there. Okay? So in self-driving cars, what do you need? Okay, we need the test track. So we have our very own test track for self-driving car. It's just at Jalan Bahar. Right? Okay, so these are some of the things that we're doing on campus. So we test for things that only apply for Singapore. Okay? Of course, self-driving cars, everyone is looking into developing it all over the world, but it's only in tropical areas like Singapore that you have rain like that really pours. Okay, this kind of rain do not exist, in US or Europe. So that's where the vision system has to work for our own climate, right? Okay, this is something very exciting as well. The autonomous bus. Okay, we are working with Volvo, okay, to have self-driving buses. Okay? And this is a project with LTA as well. Okay, no drivers, but the best thing, it is electric. It's an electric bus, right? So less pollution, and you can see that if you talk about electric bus, you need to charge them. So we have this lamppost things, okay, that would be situated around Singapore when this goes into play, and the bus should look up for this to be charged as it plows the roads of Singapore. All right. So again, give it another few years, some of your SBS buses will be like that. No driverless and electric. Okay. So if you talk about driverless vehicles, the most important thing would be the eyes of the vehicle, isn't it? Okay. This is where artificial intelligence is used to improve computer vision. They have to recognize things. They have to recognize that, oh, there's a car coming, there's a bicycle there, somebody is dashing across the road, and things like that. And again, it goes down to basic machine learning, deep learning, and things like that. And with that, we have again signed, we're still talking with them, but it's more or less confirmed. We're going to have a collaboration with SenseTime. Everyone has heard of Alibaba, but how many of you, show of hands, have heard of this company, SenseTime? Oh, some of you. Okay, very good. SenseTime is currently the world's largest startup. Okay? Even as a startup, he has garnered $3 billion in investments. Okay? It's incredible. What are they good at? They are good at facial recognition. All right? There has been a long time challenge of pitting us humans against the computer in facial recognition. Okay? Who can recognize your friend better, the computer or you? And humans have been winning this challenge for the longest time, until I think about 3 years ago, right? The computer beat the human in recognizing our own friends. Finally, it happened. Okay? So SenseTime came up with this technology that beat human in recognizing people's face. Okay? And this technology has since been put into play in places like Shenzhen. Shenzhen, you know, is bigger than Singapore. More people than Singapore. And they work with the Shenzhen police over there. And they implemented this system with the public cameras all over Shenzhen. The very first day that they implemented facial recognition into Shenzhen, they caught about 6 criminals across Shenzhen. So if you are a criminal in Shenzhen, you cannot hide. Okay? They caught some in a stadium watching football. Boom, oh, there it is. Okay? I think one of them said, okay, you caught me, but let me finish the game first. Okay? So these are what you see in Hollywood movies, right? The Big Brother eye and things like that. It's already here. Okay? The only reason why it's not being implemented in many countries like Singapore is privacy, right? Okay? Imagine you implement in Singapore. I mean, imagine a lot of wives will be calling the police. Hello, police. Yeah, my husband didn't pick up the phone or turn off the phone. Can you tell me where he is? Sorry, ma'am. Hold on a while. Oh, he's in Geylang. What is he doing? Oh, he's having beef kway teow. Okay, not so bad. Yeah. So it's already here, this technology. All right. It can be used for security and surveillance as well. Okay. Imagine, you know, for example, in a shopping center, before the person actually shoplifts, right? He starts to behave differently. Do you agree? Okay. So all this can be picked up by the system, so that you don't have to have, you know, multiple security guards looking at many screens, and even that, I mean, we only have 2 eyes, it's impossible to do that, right? So you have systems that narrow it down, you know, to focus that, oh, look, this guy is behaving weird, okay, erratic. He may steal, so all the attention goes to that person. Okay? In the university, instead of us professors walking around invigilating to make sure that students don't cheat during the exams, well, we can sit down. We have a camera vision system, and as we know from experience, before the person cheats, he will behave erratically already. Right? So all this can be put into place. Shoppers' insights. You know, a lot of companies would be very interested to track shoppers, where they walk in the shopping center, how they buy things, they look at this, they go around, they think for 5 minutes, they come back, and they decide whether to buy that item or not. So all this can be collected data, okay, and can be used to improve the product, for example. Okay? We're building this as well. We talk about autonomous systems, right? Okay, it is an autonomous VTOL. What is a VTOL? Vertical takeoff and landing system. Okay, in short, flying car. Okay, but it's not like that. It's like that. Okay, which is very important for Singapore context. Okay, the technology is such that this is becoming more of a possibilities. I'm sure you have read some of it. So we want to build Singapore's first flying car as well. We've got a long way to go, I must admit. We just started. Okay, this is where we are. But it's flying. Okay, but this one is like that. Okay, so the next one we'll build probably as big as this thing. But flying this way and, you know, going off and then landing this way, that is already marvelous. But what we want to do is to make it autonomous. No driver. That means you can imagine, most of us live in flat, right? So imagine 11 p.m. and you think, oh, how I wish I can have that barbecue stingray in Malacca now. No problem. Take out my handphone, I grab flying car. Okay? So you can imagine, not too long, maybe 10, 15 years from now, your Grab flying car will land on top of your HDB flat. You go up, take the lift, you go into it, you zoom, within 45 minutes it's in Malacca. You have your barbecue stingray, and you're back by 1 a.m. in your own home. Okay? Possible, really possible. Can't put my money on it, but we are working on it, right? So again, all these are very, very good examples of what the fourth industrial revolution is all about. The integration of us people inside this vehicle, okay, the physical system, all these robotics and wonderful machines, and more importantly, the brain, okay, to make sure that it is safe, okay, and it doesn't use unnecessary manpower. One of my professors is even doing this. He said, I don't want to build robots. Okay? I'm going to plant a chip onto a beetle. And then I'm going to control the beetle. So the beetle becomes my robot. So he called it the cyborg beetle. Okay? So on command, he can get his beetle to fly left, fly right, go forward, stop, go up, go down. Okay? So this, again, it's, in my opinion, is a very, very good example of the fourth industrial revolution, isn't it? The biological systems combining directly with the cyber and physical system. Okay? So what's the use of this? Imagine a building collapse. Okay? Instead of people trying to hunt for survivors, you send all these cyborg beaters into the crevices and holes to look for survivors. That's one very good use of such technology. Here in NTU, we host the Singapore Center of 3D Printing. You heard of 3D printing, right? Very interesting. But going forward, what's interesting is that you can 3D print, of course you can 3D print all the different parts, even metal parts, but we can 3D print human parts as well in the near future. And food, 3D print food, your favorite food, okay? So with such technology, what are we looking at? We are looking at the future of manufacturing. Let me show you how the future of manufacturing looks like. It's very, very messy, but in the middle of it all is again us, the human being. Okay? So future of manufacturing is such that the human being is the center of it all. You think of the product that you want to manufacture, and going forward is all about customization. Okay? You will build the shoe that only you have. No one else in the world has it. Okay? So such thing is possible. How is it possible? Again, with Internet of Things, the connectivity, the factories of tomorrow, they only will build a certain product and no other. Okay? So let's say you talk about tubes, okay, ceramic tubes. There will only be one factory supplying all the ceramic tubes in the whole world, and they can be all over the world. Okay, and as you design your product onto in your computer, okay, automatically they will source out for the factory that will produce that part. Okay, and they will be all sent together to an assembly point where your product will be assembled. Okay? So going forward is going to be high mix, low volume. Okay? Traditionally in the history of manufacturing is always high volume, low mix, right? Because you want to build many of the same product. Okay? And that's how it's profitable. But going forward is the reverse. It's going to be high mix, low volume. Okay? It's customization. And in such factories of the future, you would expect robots like this. Okay? This was in the news recently. A robot that can assemble your IKEA furniture. It may look simple, but I'm sure a lot of us have assembled IKEA furniture. It's not that simple right now. Huh? The holes do not really fit. Right? That's true. Yeah. Robots are good when it's totally accurate. You know the hole is there, it's exactly so big, and then you put the pack into the hole. But this robot is able to adjust. It's able to, oh, it can't fit, never mind, I try to do that. Okay? So there's a lot of human involved in this robotics, and robotics by itself is becoming more human. Okay? So that is also required in the future of manufacturing. And the last thing I want to talk about is it also affects the university, okay, the fourth industrial revolution. Okay? The way we teach students now, totally different when most of us were in school, 10, 20 years ago. Okay? You already heard of technology-enabled learning, flipped classrooms, okay, lecture on your iPad, and things like that. Okay, but what's going forward? Going forward, we are using learning analytics. Again, it's about collection of data. Okay, I can tell you that we just passed out our first batch of medical students, NTU medical students, into the workforce. Okay, they are now doctors serving in the various hospitals. 5 years here in NTU, they have never attended a lecture. Okay, all their lectures are online. Okay? And they are supposed to do group work, group-based learning, and as they learn, as they do their assignments, they are actually being tracked by the system and by the lecturer. So if they have a quiz, okay, the lecturer will be looking at the dashboard and, oh, okay, that student is taking a long time to answer these questions. He is weak in that particular section of the lecture. Okay, or from there, online, he will know, he will pick up all the students who are better and the weaker students. Okay, so all these are analytics that we are also putting into, I mean, those are the medical students, but we are also looking into doing the same things for our other students. So even as a student watches a video, okay, of a lecture on a particular topic, okay, the time spent watching on the video, where he pauses along the video, okay, will tell us that, oh, he's not sure about that part, okay, or he rewinds, then we know, okay, this student is weak in that part, okay, and then we'll fit different styles, learning styles, okay, students nowadays, it's all about variety, okay, I only want to attend lecture at 2 a.m., okay, fine, go ahead, okay, do it at your own pace. So we will cater for all this customization going forward, so that the outcome is very, very simple, is to ensure that our students get the best out of the learning experience within the university. All right? Okay, I'd like to end off with this. Look at this picture. 1990 in New York City. Where is the car? Can you see it? You see, it mostly are all horse carriages, isn't it? But there's one car. There it is. Okay. Fast forward 13 years later, 1913. Where is the horse? Where's the horse? There it is, all cars. Within 13 years, this happened. Okay. So what I'm saying is, there's no stopping an industrial revolution. Okay? The most we can do is to embrace it, to embrace the changes, to recognize that certain things, obviously, the machines are better and there's no stopping it. Right? Okay? But we live our lives as human beings and we are still human. Right? And we have to recognize that we are not robots. Okay? We have compassion, we have dignity, empathy, kindness, love, respect, and so on. And this makes us humans. Okay? And the robot can never replace this for now. Okay? So we are humans, and let's see how things go in the future. With that, I thank you. Okay, so now let's have something more interactive. Okay, I'm going to introduce my two panel members that I've invited. Okay, the first is Mr. Sam Lee. Okay. He studied at Imperial College, University of London, and graduated with a master's degree in engineering. And after practicing as an engineer for a number of years, he became an entrepreneur. He has founded companies in Singapore and China. His current companies are into robotics, Internet of Things, and artificial intelligence. Okay, he has designed and built robots such as pallet robots, delivery robot, and security robot. Our next panel member is my colleague, okay, Professor Ong Yu-Soon. Okay, Yu-Soon is a professor at the School of Computer and Science and Engineering here at NTU. He is also currently co-director of the Data Science and Artificial Intelligence Research Center and the Singtel NTU Cognitive and Artificial Intelligence Joint Lab. And he has served as the chair of the school for 2 years. He's a fellow of IEEE, okay, and founding editor-in-chief of the IEEE Transactions on Emerging Topics on Computational Intelligence, a top journal. All right. So his research interest lies in artificial and computational intelligence, spanning mimetic computation, evolutionary and transfer optimization, and machine learning. And he has been recognized as a Thomson Reuters highly cited researcher in 2015 and 16, and amongst the world's most influential scientific minds. So our friend here is not only a top AI scientist in Singapore, he's a top AI scientist in the world. All right? Okay, so I'm sandwiched by two incredible people, and let's talk about the future. So, yes, questions, that's fast, great.
Hello, thank you for the lecture, it was absolutely wonderful.
Thank you.
But as you said it over and over again, it's pretty scary. The question that I want to ask is not exactly with regards to the science, but something a bit more abstract, so I hope that it would be entertained. One of the reasons why I chose to be an engineer is because industrial age, so this is one of the reasons why I came here, because it's quite interesting for me as well. But the lecture that I heard, it basically says that the job sector is shrinking faster than we can produce new jobs for human beings. That's what I got from the lecture. And one of the props for industrial age or the first industrial revolution is it created so much amount of job that it gave people hope and jobs and like money for the future. So what I'm asking is, if there is a fourth industrial revolution and if we are pushing the humans away from it, how much hope do you have for that industrial revolution? Because ultimately industrial revolution is for the human being, as you said, humans are on the center. And the second question is kind of something like, if you're producing your first medical student, and if you're producing a chip that can take surgery away from the medical student, isn't that counterproductive? I mean, what will you have medical students do? So, thank you.
Okay, I'll answer the second one first, right? Again, it seems scary, but then we are actually trying to preserve the bandwidth of the medical profession to do the job that a human is supposed to do. All right? An example, would you want a robot to tell you, sorry, you have cancer? Or would you want a human being, a doctor, to tell you, I'm sorry, you have cancer, but let's look at how we can treat it. And these are human touch that cannot be replaced by a robot. Okay? Diagnosis, that also is, even though you have all this data that is available, but in terms of actual diagnosis, you still want a human to be signing off as saying that, okay, it's likely that you have this ailment or that ailment. Okay? You can't have the whole procedure done by robots. So what we want is really, instead of like the gastroenterologist, my friend, okay? He told me that just to use that tube, the colonoscope, it takes 2 years just to train how to use that scope. If you have robotics and AI in this, then you don't have to train to use that. You can use your time better to look into diagnosis, to look at actually the therapeutics of how you face the disease and your interaction with the patients. All right? So there is a subtle difference, and there is a line where what the machines should do and cannot do. Right? So that's the answer for my second question. For the first question, you want?
I can't remember what is the first question.
Sorry, that was a bit long-winded, so I'll try to rephrase it a bit shorter. It's that ultimately technologies are for human beings, and we are facing a population of 7 billion to 8 billion people. And we are shrinking the job sector from mundane works down to specialized work, and it seems that we are even shrinking that from specialized work to even more specialized work and then probably nowhere. So how, will this industrial revolution itself be self-serving? Because ultimately we are trying to serve the human being, are we not? So yeah, that's...
Okay, my opinion is that I don't think we need to be overly worried. Jobs will be replaced, but new ones will be created. Okay, what kind of jobs will be replaced? Things that are repetitive, routine, like dishwasher, receptionist, security guards. These are jobs that are quite mundane. And this, you will see it to be replaced in a couple of years. Even as an accountant, there are different roles different types of accountant. For example, one that does simple bookkeeping of your income tax and so on, especially for Singapore. Our income tax is extremely easy to file. Such things will be replaced over time, simply because humans make mistakes, but not the machines. Once all these data are digitized, they will not make mistakes when it comes to calculations. So some of these jobs will be lost, but new ones will be created. So there's always two sides of a coin. For example, one of the company that I work with, Honda, for example, they have gone not so much into autonomous vehicle, but into vehicles that are working and making the driver feel good about driving. Because their belief is that driving a car is an experience that people want to have. So the belief is people enjoy driving a car. So they follow a symbiosis type of a model, where they come out with technologies that will help, that will make the driver enjoy it even better. So I would say there are two sides of things. And I'll add to that where what kind of jobs will remain? Jobs that requires creativity. So those CEOs will stay there. Professors that only lectures may face a problem in the future because everything has gone e-learning. But professors that does research and apply learning analytics will remain. Artists, anything that requires to a certain extent some form of creativity, those jobs will remain. So I think my advice for everyone is to be open-minded. I think it's important in this era to learn, unlearn, and relearn. And in the university, we preach the values of learning to learn, not memorize. You don't need to memorize anymore because Google has everything. So this is my view.
Okay. So Sam, from an industry perspective, what do you have to say?
Hello.
Yeah.
Hello. Yes, I'm in the industry, so we have been building robots and AI systems. And your question, I don't have the answer, but just to share with you how fast things are changing. So recently we signed up for an exhibition, IPI exhibition, and we said, okay, let's design and build a robot. So it took us 2 days to design the look and feel of a marketing robot. It took us 3 days to print it, and took us 1 day to assemble. So we built a robot in 7 days. So that is how fast things are moving. And after that, we say, let's add in a voice, AI voice. So we say we want the system to be able to make appointments or make bookings with a restaurant. Say you call up and you say, I want to have a dinner tonight for 2 people at 7 p.m. So it took us 3 days to build this AI voice system. Of course, we used Google as the engine behind. But it just takes 3 days for us to build this AI voice system. And today I met one customer, he wants to have an AI voice to handle complaints. You know, residents call up, there's a leakage, the rubbish is smelly. So I think very fast, within 12 months, the voice system will be implemented in many industries. Google released this in May, right, in the yearly Google conference, and it takes us just 3 days to build the system and probably another 1-2 months to implement it. This will, of course, improve the lives of humans, improve productivity, improve competitiveness. But as to these people who lose their jobs, what are they going to do next? That one, I don't have the answer. Okay, that's from what we are doing in the industry.
Okay. Another question? Yes, please.
Hello. Hi. Thank you for your talk. Up until now, we have been witnessing a very exponential growth in all technological developments. Do you think in the future, either near future or far future, there will be a plateau? So, because there's only so much that our brain can take. So, do you think humans will reach like the limit of knowledge that we can have?
Okay. A real story, I can't remember which year, but it was about 100 years ago. Okay? You know, when you have a new invention, okay, in the industry, in the academic world, you file a patent, correct? Intellectual property. That is very important. That is to protect your idea. So about 100 years ago, and they were reaching like, I can't remember the number, like 500,000 patents. And they said, that's it, we will stop at 500 patents all over the world. This was in the US. Because there cannot be more ideas. Right? Okay? And obviously that was a mistake. Yeah. The filing of patents have since, I don't know what is the number now, what, 500 billion? I don't know. Okay, so imagine if that idea was implemented to stop at 500,000 patents. Then there will be no inventions since 100 years ago, which was ridiculous. So what I'm trying to say is that things are growing exponentially. Okay? I don't think it will ever plateau. It may slow down, I don't know. Okay? But there's always a paradigm shift in technology. Okay? Things that no one has up to now thought of. And that will change the whole game altogether. Right? So, in short, my answer is there's no limit to creativity. That's for sure. Yes?
Thank you for the great talk. I wanted to ask about the AI singularity. Yeah, I can see your expression change with that. So it has been posited that given the exponential growth of especially silicon technology with Moore's law and a lot of equivalents in other technologies as well for Moore's law of exponential growth, show that at some point machine intelligence or artificial intelligence would reach the level of human intelligence. And since machines process data much faster than we can think, they will just cross, and then everything that human beings are capable of doing will become irrelevant. So at that point, we will not have any jobs left to do. And for that, are we preparing ourselves in a certain way to understand how the economy is supposed to work, some universal basic income, or any other ideas like automation tax that Bill Gates has proposed, or anything else like that that has been in the research side as well as on the industry side? Thank you.
Okay, thanks for the question. Can you hear me? Okay. So don't be overly worried, as I mentioned. AI has not reached a stage where it's going to take over humans, not at this moment. So all this, if you think about it, I'm not sure whether you're aware of the history of AI. So AI was first coined in a conference in the 1960s or 1950s, somewhere around there. And then there was quite a bit of a hype also on AI. And after trying out on expert systems, I don't know whether you heard of expert systems, they found that it's working, but not exactly scalable. So it has been used in the healthcare, for example, when you see a doctor, for example, they tell you that, is it a doctor that tells you the diagnosis, or actually you telling the doctor the diagnosis? If you think about it, it's you yourself telling the doctor, I don't feel well here, I have a flu. Oh, you have a flu, I give you flu medicine. Right? I have a fever, okay, I give you Panadol. So if you think about it, it's just a simple if-else rules. If you have flu, take this medicine. If you have headache, take Panadol. So that was something that they have used it also in the past. But then, first of all, it didn't pick up because of social reasons. And also, to build any new systems, you need domain knowledge. You need a doctor to actually come in to tell you exactly what these rules are. And it takes a long time just to build every single expert system. And because of that, expert system die off because it's not scalable. We enter the period of AI winter. Until the time where we reach Deep Blue, you see that a machine with brute force compute power, we could win humans in chess. Then subsequently, you have chatbots, you have Sri, right? You have IBM coming out with their Watson that beat Jeopardy in the Jeopardy game. And then subsequently, AlphaGo. That finally, because Go is such a much harder, complex game compared to chess, and finally you have a machine that beats human. So the technology that's being used now, I'm sure you all heard of this deep learning. In fact, the algorithm has existed quite long ago. But only until machines or compute power become so cheap, data becoming so immense, there's so much data. So data is what we call the new black gold. Okay, it's the new black gold. So it's a gold because using the data, you can create models that all these machine algorithms could learn from. And with that, it can do a lot of predictions. So you fuel with this data to these AI algorithms. Okay? But having worked in AI for some time, I have to say we are still very far from what human is capable of doing. Why is that so? The way deep learning works now is that it needs to train everything from scratch. And it needs so much data in order for it to work. And it is very vulnerable. So there's still quite a bit of challenges that need to be dealt with. Okay? One of them being the ethics. One thing that we do in building all this model is that we use the data, but you know that garbage in, garbage out. So for example, the reason we shield our kids from porn is because you don't want them to pick up the wrong thing, right? But at the moment, a lot of data are being used, possibly in the wrong way. For example, I could have a data that has 10 data points. Out of the data points, 9 of them is having one feature that says that it's female, and the other one is male. Obviously, the prediction or the model will give you a higher probability of predicting that this person is male. Isn't it? So data bias is also an issue. So there's a lot of ethics issues that need to be ironed out before anyone could really use it. Okay? And there's always this question, if an autonomous car were to hit somebody, okay, on the left you have our Prime Minister, on the right you have a pregnant woman. Should it knock onto the wall, steer left or steer right? Who dares to make the decision? Unlike humans, you can't pry over the head to see how he makes the decision. But for the machines, you can. And if you were to program it wrongly, someone will get into trouble. So there's a lot of social issues, a lot of things need to be addressed before we can reach what we call, the issues that we brought about. Okay, so these are just some of the challenges. I can go on and on for the whole day on what are the other challenges. I hope that answers your questions.
Okay. For the record, my friend here is not a robot. Yes, anybody else? Yes. Oh, yes.
You brought great examples leading exactly to my question I just wanted to ask. AI is of course fantastic, all the opportunities you can do with that, but at the end it's software. There's no software, I hope you agree on this one, which is bug-free. So a lot of risks, of course, and my question is what about the regulatory requirements or even legal requirements? So where do you see the needs, and can you perhaps even share, are there activities already really regulating this, or at least avoiding that these systems get viral?
Okay. I think in terms of regulation, it varies from countries to countries. I was involved in one of this committee on ethics and looking at how, making sure that data that's been used to build models are not biased and so on. The US has already been looking into this, European as well. Whereas I think the country that's most liberal about it is China, which is why AI is blooming there. Because data can be collected so easily. So I guess in a way, which is why everybody is getting into a frenzy of trying to do AI. Because if you don't do it, people will be very hungry there to come out with all different types of AI products. And it's already happening. I'm not sure whether you're aware of the term that China uses. You heard of 997? There is a term that they use in China, the number of days and hours you work in China. From 9 to 9, 7 days a week. And I have a student who is working in a so-called work-life balance company. It's called 996. So this is happening. If the rest of the world doesn't follow and doesn't compete along with them, you know what will happen. So I just want to say that, I want to add that while AI hasn't reached a stage where it will conquer humans, take over humans, but there are a lot of opportunities. Imagine this. Deep learning is capable of providing us two key senses. The two key senses I would say are the sense of sight and the sense of hearing. There's the chatbots, the speech aspects. The sense of sight has lots of opportunities. Bear in mind, it's not just human sight. Machine sight is multiple spectrum. Anything bionic, any spectrums it can see. So you can use any form of devices and see any spectrums. Imagine that. So you need to open up your mind, think of destructive opportunities to use this technology. And that is what is really happening in China. They come out with all kinds of products in all fun ways. You can go to Alibaba, Taobao to buy a basketball that has sensors inside that tells you how many times you bounce it, and it's sent to your phone. All kinds of interesting, creative products. You think of it, they already have it.
You should also know that recently, China, they are teaching artificial intelligence to secondary school students already. Yeah. So Sam, you have companies in China. What's your perspective?
I suppose this part about creativity is something that we are still years ahead of the AI and robots. And that is really exciting because with creativity and with the technology now, we can create very fast. It's unlike last time where maybe you take 5 years for product development. Now from ideation to prototyping, it could be just 1 month or 1 week, which means to say that huge value can be created just by thinking, just by writing down, and then just by having some design, someone prints it for you, someone assembles for you, and then with this business plan, you have created $1 million or $10 million. I think that is really what AI and machines free up humans from the mundane work and allow us to have time to do all this higher value quality work. And my experience in China is that really, I think let's do first, okay? And over time, we'll know that what works and what doesn't work. The legal system can come in later, just like they did for their bike sharing, right? After bike sharing a couple of years, then now they start to have regulation. You must be registered and so on. I think perhaps technology moves so fast and it takes time for the legal system to catch up. That is one approach maybe the Singapore government can adopt. Let's just do first and see what happens.
Okay. I think, yeah, you have a question? Yeah.
Hi, I just want to know, get some advice from scientists, AI scientists, about the robot Sophia. Yeah, I just want to know how true it is, and will we be actually developing robots like Sophia? Thank you.
If I could ask you, what do you think is fantastic about Sophia?
Yeah, just want to know. I don't really know more about Sophia, so that's the reason why I'm asking.
Right. So I'll be very frank. There's so many robots that are being invented in the recent years. I can't remember which one Sophia is. That's why I'm asking you, what is the features that you think about robot Sophia that's
Sophia,
unusual?
Okay, Sophia is actually having a smart conversation in public.
Okay.
Yeah, so on public television.
Right.
So communicating and things like that, because I believe AI has several steps, ranging from speech recognition, learning, planning, and problem solving.
Okay.
And 4 of this category, let's say we can actually exceed what human intelligence will be.
Okay, I'll say that I'm not sure whether you're aware that the first chatbot actually was called Eliza. It was invented before the AI winters. So that's like 1960 or 70s, right? So there's been chatbots already been invented. It's just how humanized it is. Okay? So the one right after the AI winter, was one that passes what we call the Turing test. That means it's able to cheat and bluff the human, thinking that it's a human and not a robot. Okay? So I would say that it all depends on when you design a robot, would you want this robot to answer the question perfectly or to make mistakes and make you feel like it's a human? So there's this rational aspects that, like what Louis said, right now we may not want, or there are people who are building irrational robots, things that are be able to understand your emotions. They are able to understand the situation that you're in. For example, like a social robots, those that are used for aging, in aging where it serves as a companion to old people, as well as educator to kids. So there has been quite good developments in these areas. So I'm not sure exactly what aspects of all these robots that you want me to go into. I'll say that all these are part of all the AI robots. Basically they are chatbots, yeah.
Okay.
Yep.
Yeah.
Question?
Let's. Time is running out, so let's take the last 2 questions.
I'd like to thank you a lot for the research that is going into the medical and AI fields, because coming from a country like India, where you don't have quality, cheap healthcare in places outside the major cities or education, I'll be very glad if robots or AI replace teachers and medical profession altogether. I'm very optimistic about that. There are side issues like jobs and all, but I think people will find time to do something that they like instead of work in mundane jobs just to get a salary. And there will come up solutions, but ultimately you'll have more people gaining than losing, just like email may have affected postmen, but it's okay. Yeah. We'll find out.
Thank you. Yeah.
But I have a...
Sorry? Yes.
I have a question. I'm a student of NTC, Nanyang Technopreneurship Center. So I want to start up on my own. As I see all the collaborations that happen here, I'm interested in spaces like AI, trying to prevent death by predicting if you're going to have a heart attack and stuff like that. But I see most of the collaborations are with huge companies, and it seems to be budget intensive. So how do you advise that we get into exciting spaces like this as a startup?
Okay. I think all of us can say something about this. You've got entrepreneur here as well. About what you said in your comment, I think it's true. Technology is a leveler. Okay? Technology enables the best service for us humankind all over the world, irregardless whether the country is rich or poor. Okay? It's just like in Singapore, we always say education is a leveler, right? You may come from a humble family, but if you do your part in studying hard, you can get your degree and you'll be fine. Yeah. So moving forward with robotics in the area of medical technology, yeah, it is true. You know, as more robots are built, okay, inevitably the price would also go down, such that anybody can afford it, right? And as I show you an example, and it's already happening. You know, you get a top surgeon to operate somebody, you know, but it's going to be very tough for you to fly that surgeon to another country just to operate on one person. But if the surgeon can stay where he is and operate from where he is, that would definitely, or he can try to supervise other surgeons who are doing this operation. I think that that is already possible. It's just ethical. It's because of ethics that we are not doing it, okay? Because ethics says that, yeah, you are operating on this person, but there's a distance of 1,000 kilometers between you and a patient. You know, what if something goes wrong? What if the internet fails you at that time? What's going to happen? So there are ethical questions that we are facing. But yes, like I say, technology would be an enabler, a leveler for everyone. In terms of entrepreneurship, okay, I've started companies. We've got entrepreneur here, okay. It is all about hitting the right spot. Okay? Why are we working with the big companies? Because we are doing great work. Simple as that. If your idea is a good idea, okay, people will come to you. Okay. And gone are the days where, oh, I know somebody, that's why I get a bigger investment or whatever. Again, with technology, with internet, if you have an idea, straight away you can share with 2 million people tonight. Am I correct to say that? Right? And then you spread the net, not only to your country, but your net is spread across the whole world. You have this idea, who is invested, crowdfunding, all this. So there's no fear of not partnering with the best. It all depends on the quality of your idea, right? Entrepreneur, what do you have to say?
Wow, entrepreneurship. Yeah, I think you must be prepared to work 998 or 997, 997. Okay, I think to attract talents and to attract capital, you must have a very big dream, big idea, right? And this idea, you probably need time to develop it. You know, it's not something that someone can copy the next day. Okay, otherwise, you know, soon you have so many copycats undercutting your price. So start out with a big idea, a big dream, something that is not too easy to do. Maybe you're still in university, right? So you can do your pre-startup by developing in your hostel, right? You spend your 3 years developing, and by the time you're ready, you're graduating, you can incorporate company, raise funds, and for the other person who wants to copy you, he might need to put in 2 years of work. Okay, so at that point in time, you have a big dream with a working prototype, and maybe the venture capitalists would invest in you, and if it works, you can very fast scale it up to many countries. Okay, I think that's my 2 cents worth.
Okay. Yeah. Last question for tonight.
Just recently, just a couple of days ago, I read an article about the competing AI, because we just talked about China. And China going so fast, and still there was a misconception about China going very fast, because it says that it still have a long way to catch up with the USA. Is that true? And what are the things that in the US are using in the public, or are they using AI in the public? That would, because I have friends who went to US and they said, oh, US is so slow, you know. But then the article was saying that China still have a long way to go to catch up with US. So can you elaborate a little bit or tell us something about what kind of AI development that is in the US? Thank you.
Okay, for this question, I'm going to ask somebody that is not seated here. Okay, I'm talking about Professor Wen Yonggang. He's from China. All right, and he is an AI blockchain expert. Okay.
Okay, it's a tough question. I happen to get educated in the United States as well. I also grew up in China. And first, I must to confess that China is still a long way to catch up with the US, especially in these more fundamental or building blocks of modern AI or the Industry 4.0. For example, the chips and the chips as well as the software OS system. And those things, first, it takes a long time to build up the capability. And second, it also takes tremendous patience to get to the stage where it is right now. And at the same time, China is moving so fast. We are moving almost in every front, trying to do things really quick and dirty way. Remember, the quick and dirty way is not necessarily, on one hand, it actually can progress really fast, but at the same time, it's not getting the same stage which you want to be in another 5 years. Basically, you moving too fast, you forget about that you need chips, you need operating system, which are not easily been able to create it, and also lack of the ecosystem to support this. And given the situation, I will think there's still some time for China to catch up with the US. And of course, at the same time, Singapore stands in a good chance to doing well in some of these aspects, because so on one hand, we are more pragmatic than when we're in the US. We can do things really more efficient. Actually, a lot of my friends are coming from China to do business or to do startups in Singapore because we are more efficient in the whole system. And at the same time, we can work with the Western world more closely to have access the technology, have access the mindset which can drive this innovation, and innovation really in a good shape. So that's my my view, but may not be the correct view. So I hope that gives you an idea. Although I'm proud to be a Chinese, but I also think there's a long way, or there's a lot we need to learn from what the US has been doing.
Thank you. Okay. So with that, I'd like to close the session. There has been a wonderful, intriguing discussion. Your questions are really good. Okay? It gets everybody thinking. It shows that everybody is looking forward, as well at the same time a bit skeptical about what the fourth industrial revolution would bring. Okay? So with that, I'd like to thank my panel members, and I'd like to thank your presence tonight. Thank you.
Thank you. Thank you. I think we would also like to thank our speaker and panelists. I think we give them a small token of appreciation. Professor Phee, thank you very much.
Thank you.
Okay. Mr. Sam Lee, thank you. And of course, thank you so much.